In this video, you will learn how to solve different problems in stoichiometry. Let's solve this problem here. Germanium fluoride is synthesized in the reaction. We have GeH4, germanium hydride or germane, reacted with germanium tetrafluoride to produce germanium fluoride. So we need to write a balanced chemical equation. We need to make sure everything is balanced. So we have 4 moles of germanium here and also in the product side. And then for the fluorine, 12, okay, 12. All right, so we have a balanced chemical reaction here. If the reaction is 91.5%, how many moles of germanium hydride are needed to produce 8 moles of GeF3H? All right, so we're given here the percent yield, which is 91.5%. Should be reaction yield. All right, and then we just have to calculate the theoretical number of moles of germane. So we're given here the number of moles of germanium fluoride, and that is the actual value. So percent yield, using the formula in solving for percent yield, which is equal to actual over actual yield over theoretical yield times 100%. All right, in the problem we're given the percent yield and the actual yield, a number of moles of germanium fluoride, which is 8 moles. So we can plug in all the given values to solve for the theoretical yield. Then we would multiply that by the mole ratio to get the number of moles of germane or germanium hydride that are needed to produce 8 moles of germanium fluoride. All right, so percent yield is 91.5% equals the actual yield, which is 8 moles. 8 moles of then we need to solve for the theoretical yield. So theoretical yield is just equal to 8 times 100 divided by 91.5. So 800 divided 91.5. So this is just equivalent to 8.74 moles of germanium fluoride. All right, so now we have the theoretical yield of GeF3H. Then we can multiply this by the mole ratio from the reaction to get the number of moles of germanium hydride. Right. So we multiply 8.74 moles GeF3H, then multiply this by the mole ratio. So 1 mole of GeH4 is to 4 moles of GeF3H. Then the number of moles of GeF3H cancel out. Then we're left with the number of moles of GeH4. So that would be 8.74 divided by 4. This is approximately 2.19 moles. So this is the number of moles of germane that are needed to produce GeF3H. Okay, let's solve another problem. 8.92 grams of indium oxide is reacted with an excess of water and forms 10.1 grams of base. What is the percent yield? All right, so before solving this, we need to write a balanced chemical reaction. So indium oxide, that is, okay, indium, formula of indium is In oxide. So an In2O3 reacted with water to form a base. So our base would be indium hydroxide. Then we balance this. We need 3, 6, 2 for indium. All right. Okay, we're given here 8.92 grams of indium oxide. And we need to find the percent yield. And then also we're given 10.1 grams of indium hydroxide, which is the base. So we start with 8.92 grams of indium oxide. We multiply this by its molar mass. So that is 1 mole of INO3 is equal to 277.6 grams of In2O3. So 277.6 grams per mole, that is the molar mass or molecular mass of In2O3. And then we multiply by the mole ratio from the chemical reaction here. 2 moles of indium hydroxide is to 1 mole of indium oxide. All right, the gram indium oxide here cancels out, as well as the moles. Then we multiply this by the molar mass of indium hydroxide, which is 165.8 grams per mole per 1 mole indium hydroxide. Okay, this cancels out. Then we're left with grams indium hydroxide. Okay, let's calculate that. That is 8.92 divided by 277.6 times 2 times 165.8. Okay, we get 10.7 grams of indium hydroxide. So now this value is the expected value or the theoretical yield. Now we can solve for the percent yield. So we are given the actual yield here, which is equal to 10.1 grams. Then we got the theoretical yield, so we can solve for the percent yield. The percent yield is just equal to the actual over theoretical times 100%. So this is 10.1 over 10.7 times 100%. This is just equivalent to 94.39% or approximately 94.4%. So that is our answer there.